What we're going over today is just a little bit of introductory information. Most of it will be review for you guys. We're going to talk a little bit about what we're going to be doing in chemistry as well as what you do just in science in general. So we'll go as quick as we can, and then you have a worksheet to do for homework afterwards. So studying science means observing the world around you and then trying to find ways to explain it. So you might be looking at something like, why is the sky blue? Or why do we see stars at night? And then you try to find a way to explain what you're seeing. You might be asking questions like the following. For example, why is the sky blue? Why does soda tickle your nose? How does a bird navigate during migration? And how does a pulley system make a heavy load lighter? See if you can figure out which of the main branches of science each of those questions came from. Earth science for the sky, chemistry for the soda, biology for the bird, and physics for the pulley. So the next task would be to think about, how do we answer all those questions? What do we actually do while we study science? We hypothesize, meaning we make an educated guess or a prediction of what we think is going to happen. We interpret the results that we get. We do experiments. Hopefully we understand what we see. We make observations. We document what we find. We share those findings. And sometimes, yes, we even have to calculate a certain answer or some data from some lab results. So now that we've talked a little bit about studying science in general, let's talk a little bit about chemistry. That's what this class is after all. So what is chemistry? This definition of chemistry is the same definition that I learned from my chemistry teacher when I was in high school, and I think it really sums up a lot of what we do in this class. Chemistry is the study of how and why stuff appears and behaves as it does. Why does it look the way it does? Why does it react with other stuff? How does it react with other stuff? And we'll talk about what stuff is a little bit later. And if we're going to be studying chemistry, we also need to know, what are chemicals? So a chemical is any substance that is formed or used during a chemical reaction. There are lots of very common chemicals that you're already familiar with. Salt, bleach, any kind of acid, of course, is a chemical. Almost everything is a chemical, or at least it's made of chemicals. Water is a chemical. Air is made of chemicals. Just about everything you can think of is or is made of chemicals. So how do we learn about chemistry? First of all, we make observations. All substances have two kinds of properties that we can observe: physical properties and chemical properties. Physical properties are those that can be observed or measured without changing the composition of a substance. In other words, you don't have to change what it is. So things that you can see or measure without altering what that substance is. Things like color, texture, odor, density, melting point, and boiling point. The last two would be the temperatures at which something melts or at which something boils. Chemical properties, on the other hand, tell how a substance interacts with other substances. So physical properties are one substance on its own. Chemical properties have to have two or more substances involved. For example, does it react with acid? Does it react with base? Does it burn? Combustion or burning is a chemical reaction. Does it react with anything? The last two of the physical properties that we mentioned as examples were the melting point and the boiling point. Those involve a change of the phase of that substance, but we still classify them as physical properties because those changes are physical changes. A physical change is one that does not affect the chemical composition. In other words, it doesn't change what the substance is. If you think about the snowman that's melting in the picture here, snow is just water, and liquid water is just water. So the change from snow to liquid or from ice to liquid doesn't change what that substance is. It's still water. There are 6 physical changes that are phase changes, and then there are some other pretty simple examples as well. Melting, boiling, and freezing would be 3 of the 6 physical changes. Other things that would fall under this category include crushing something, breaking something, squishing something, ripping a piece of paper, anything that you don't change what the substance is. Chemical changes are different. A chemical change is one where the substance is changed into something new. You have changed your starting materials into something different. The way that you do that is by rearranging the atoms. Atoms are a lot like Legos. You can rip them apart and put them back together in a completely different way. There are several signs of chemical changes, how you know that a chemical change has taken place. Bubbles where there weren't any before. If you see a spontaneous change in temperature, so for example you mix 2 things together and the temperature changes. If you see a precipitate form, we'll talk about what that is on the next slide. If something burns, or if something spontaneously changes color, or when you mix 2 things it changes color. Time out for vocabulary. What's a precipitate? You're probably used to hearing that word precipitation in terms of the weather forecast. It usually means rain or snow, something falling from the sky. When you see a precipitate form during a chemical reaction, a lot of times it looks, maybe on a small scale, like in the test tube, like it's raining or snowing. There'll be something falling in the test tube, and little bits of solid is usually what you see. So a precipitate is a formation of a solid during a chemical reaction. Usually occurs from 2 solutions being combined or 2 liquids being combined. And what you'll see is that liquid turns cloudy, or you see floaters, almost like it's raining or snowing inside your test tube. Now we need to do just a little bit of review. Hopefully this information is not new to you. We're just going to make sure that you still remember it before we move on to the harder material. States of matter. States are an important physical property. We talked about that already. There are 3 main states of matter: solid, liquid, and gas. We are not really going to deal with plasma in this class. We don't have the equipment for that. So solid, liquid, and gas is all we need to worry about for now. In a solid, the atoms and molecules are held close together. They have very little freedom to move. This makes them very low in energy. They don't have a lot of energy because they're kind of stuck in place. And solids then have a fixed volume and a fixed shape. A comparison I usually make is if you could imagine each student in this room as an atom. When you're stuck in your desks, you would be a solid. You're very close together. You're fixed in place. You usually have a low amount of energy when this happens. And you have a fixed volume and a fixed shape. You take up the space that's allotted with the desk arrangement. It's a very neat, orderly arrangement, and you don't have a lot of variation with that. In a liquid, atoms and molecules are still held pretty close together, but they have a little more freedom to move. This gives them a little bit more energy, like a medium energy. I usually say that the atoms in a liquid can slide past each other. This gives liquids a fixed volume, but a variable shape. That means they can take the shape of their container. I usually use the comparison of students on lab days for a liquid. You have a little more freedom to move within the back area of the classroom. You can slide past each other, even though you're still pretty close together, and this usually gives you a little bit more energy. And then we have gas. In a gas, the atoms and molecules are far apart. They have a lot of freedom to move, which gives them a very high amount of energy, and also gives them a variable volume and a variable shape. Gases will expand to fill any container. They can also be compressed to fit in most containers. Gases would be like students that hit the door at 3 o'clock. You expand into the parking lot, you have suddenly a very high amount of energy, and you can fill any container. So You can be contained in the parking lot, or you can escape to another location. There are 6 phase changes or changes in state, as I mentioned earlier. These are important physical changes to know. We deal with these fairly often, and we need to know what they are. Freezing and melting are the changes that occur between a liquid and a solid. Evaporation and condensation occur between a liquid and a gas. And sublimation and deposition, or sublimate and deposit, those are the changes that occur between a solid and a gas. And this is a phase change diagram to show where each of the phase changes takes place that I have color-coded so that it kind of looks like a cheeseburger. If you follow the arrows and you go from a solid to a liquid, that's a melting phase change. If you go from a liquid to a solid, that's freezing. If you go from a liquid to a gas, that's evaporation. From a gas to a liquid is condensation. If you go from a solid to a gas, that's sublimation. And from a gas to a solid is deposition. We do still have a worksheet to turn in for tomorrow, and you are still having your safety and policies quiz tomorrow, so make sure you study for that. Feel free to email me if you have any questions, and hopefully I will see you tomorrow.